Hello, in this video we're going to look at a problem of which we're trying to figure out the number of possible keys that I can create so that I can then have a hidden message, for instance. So what I mean by this, first off, is that in this machine you have 26 letters per spoke wheel, and then you have 3 different spoke wheels. Notice that they're labeled appropriately as 50, 60, and 70. Now, what this means is that essentially in creating your key, you first need to determine the order of which that the spoke wheels will be presented. So either 50, 60, 70 or 50, 70, 60. The next thing is that you would have to create your own 3-letter key, because once you find the key, then in that case you just go about rotating this spoke wheel to find the assigned letter. So like, for example, like if you put a U here, you would just look over here and see what letter do you get assigned to that U. You then rotate one more time for any following letters. So like if you rotate it to, let's say, X, you would just look and see what letter comes up in the middle part, and that would be the letter that comes up for X in that case, for the second letter. As you repeat, you just kind of alternate between the 2 wheels essentially. So once you create your message, then it's actually in that sense encrypted, because then each letter is just getting reassigned appropriately. But here's the thing though. What if we had a hidden message already? Like, we had a bunch of letters, for instance, and we needed to figure out, the decryption of it. Well, if, for example, that we just needed to guess until we got something that made sense, then that would mean that you would have to try all possible keys. So to determine all possible keys, it's just a matter of figuring out what are the total number of ways that we can create a 3-letter key. Okay, so in any case, we can think of it like this. First off, we have to make note that the order definitely does matter. The next is that you have that there's 26 letters. And then the next is that you have that there are 3 spoke wheels. Okay, now with the letters, technically you have that they can be repeated. So we have that repeats are allowed. Okay, now let's say that we wanted to compute the total number first off. So as mentioned, we have that we're creating essentially a 3-letter key. So if we create a 3-letter key, then we could think of these as like different spaces. So here's the first, here's the second, and then here's the third. Now, if I think of it like this, for example, I have that, well, let's say that we choose a letter first off. So we have 26, right? But we choose another letter in that case, another 26. Okay, because remember that you're choosing a 3-letter key. So in that case, you're thinking of T, cat, let me see, toy, and so on. So you're just thinking of like 3 letters that make sense to you as a key. That could even be ATM, for example. Now, after that, you have that there are 26 letters that you can choose for the 3rd spoke wheel as well. Now, in that case, if I was to multiply this by using my product principle, you have that, so you have 26 times 26 times 26. But essentially that just tells you that you end up with 26 to the third power, which if you get 26 to the third power, that's going to be 17,576. Okay, now if that's 17,576, that's only the number of ways that we can, choose those letters. Okay, but notice that there were 3 wheels though. Okay, so there's 3 wheels. So we also have to think of, well, in any case, as I choose my first letter, it's going to be also dependent on, what wheel was it, okay? So to make it simple, we can actually just think of it like this. Take 3 factorial, because remember that you have that order definitely does matter. So in that case, you have that there are a total of 3 factorial because you have that there's 3 choices to make of which the order matters. So in that case, it's kind of like the lining up of the individuals so that they can have their picture taken. You have that would just be n factorial essentially. So you take 3 factorial and you're going to multiply that by 26 to the third power, but then that's going to give you 1,005 and 456 possible keys. So if I was to basically give a message, then in that case you would have to go about guessing the key that was used in order to encrypt the message. So if I choose a particular 3-letter tab or key, then basically I can then encrypt a specific message. So for instance, if I was to write out the letters like M, L, G, W, Q, and then followed by N, U, S, G, then in that case you would have to go through the different keys in order to figure out like what was the original message from here. Notice that as you choose each letter, that all the spokes will rotate essentially. And you have that some of these, both of these actually they're ordered properly, but the middle one, it has that they kind of like skip every letter or so, something like that. So, but in either case, even if it was ordered properly, it would still come out to the exact same number of ways in either case. Now, if you actually were to decrypt this using the proper key, essentially you would then figure out that the hidden message for this particular encrypted one is that, well, using the right key, basically the hidden message was I love math. Okay, so the only thing though is that what was the key that I used, and actually the key that I did happen to use was the word tab. So I just chose, just randomly by using that my key happened to be the word tab, but I needed to remember that I ordered the spokes by 50, 60, and 70 respectively in order to encrypt this message. Of course, in order to decrypt, you would locate the right spokes, then you would rotate the key to the proper position. That way when you rotate, the letters will also rotate properly, so that when I look up M, I'll get I. When I look up L, I get L back, and so on. And yeah, it just comes out to the phrase, I love math.